There are instances that the limit becomes a different case after the initial differentiation. Just continue differentiating if that's the case. Welcome to differential calculus. Evaluate the limit arctangent of x times ln of x as x approaches 0 from the positive side. Substituting 0, what we have is 0 times infinity. The product should appear like a ratio to use L'Hopital's rule. For the first try, let's place arctangent of x as the numerator and the reciprocal of ln of x as the denominator. Start with L'Hopital's rule by differentiating the numerator. The derivative of arctangent has the pattern of 1 over 1 plus x squared. Then attach d over dx of x. The denominator uses quotient rule, where the denominator is the square of ln of x. Using low d high minus high d low, the first term then becomes ln of x times the derivative of 1 minus 1 times the derivative of ln of x. Completing the limit, simplify dx over dx as 1, and d over dx of 1 is 0. The numerator is then simplified as 1 over 1 plus x squared. From the denominator is still the square of ln of x. Then its numerator is negative 1 over x with the derivative of x over x through chain rule. Dx over dx is 1. So the limit then becomes 1 upon 1 plus x squared all over negative 1 upon x times ln of x squared. Rearrange terms to have a simple fraction, making x times the square of ln of x all over 1 plus x squared. Placing 0 for x, we then get negative of 0 times the square of ln of 0 all over 1 plus the square of 0, which then still ended up as 0 times infinity. Work on a different configuration, where the numerator is ln of x and the denominator is the reciprocal of arctangent of x. From the numerator, ln of x is 1 over x, then attach chain rules d of x upon dx. The denominator uses quotient rule, with a denominator of the square of arctangent of x. The numerator has two terms, starting with arctangent of x times the derivative of 1 minus 1 times the derivative of arctangent of x. Clean up the limit with dx upon dx as 1 and the derivative of 1 as 0. So the limit becomes 1 over x all over 1 over 1 plus x squared. This is the derivative of arctangent x. Then attach dx over dx from chain rule. Its denominator is the square of arctangent of x. Again, dx over dx is 1. So placing the denominator of the denominator up and rearranging the other terms, the limit becomes the square of arctangent x all over x times 1 over 1 plus x squared. Place the lowest term up again to have the binomial 1 plus x squared times the square of arctangent x all over x. This is the simplified limit, so substitute 0 to x and get 1 plus 0 multiplied by the square of 0 all over 0, resulting to 0 over 0, a case 1 format. So let's continue differentiating the limit. We start with the derivative of x from the denominator, which is 1. From the numerator, we use product rule. The first term has 1 plus x squared times the derivative of the square of arctangent x. The second term has the square of arctangent x multiplied by the derivative of the binomial 1 plus x squared. Focus on the end of the limit. The derivative of 1 is 0, and the derivative of x squared is 2x, thus producing 1 plus x squared times twice of arctangent x with d over dx of arctangent x through chain rule. The second term has 2x times the square of arctangent x. The first term then is arranged as 2 times 1 plus x squared with arctangent x, then the derivative of arctangent x is the pattern of 1 over 1 plus x squared with d over dx of x. The second term is just copied as no further differentiation is required. Dx over dx is 1, and the binomial 1 plus x squared also cancel out, shortening the first term into 2 times arctangent x. This is the simplest transformed limit, so plug in 0 for x, making twice of arctangent of 0 plus twice of 0 times the square of arctangent of 0, which then turns into 0 plus 0, which is eventually 0.